Welcome back. I know yesterday you talked about rectangles, parallelograms, and triangles. We talked about how to find the area of those shapes, how to label them correctly. We learned that area is always labeled in units squared. And we learned how to find a missing side length if we were given the area, so you basically had to work backwards. Today we're going to move forward into 3 new shapes. So all of the shapes we're going to talk about today are quadrilaterals, so they all have 4 sides. And the first one we're going to talk about is the trapezoid. So the trapezoid is basically a quadrilateral, a 4-sided shape that has 2 parallel sides. And to find the area of a trapezoid, we just take 1/2 h b1 plus b2. Okay, and all you have to remember is that the h is the height, and the b1 and the b2 are the bases. So all you have to do is remember h is the height and b1 plus b2 are the bases, and the bases are the parallel parts of the trapezoid. Another way to think about this formula is add your bases, multiply by the height, and then divide by 2. So that's basically what we're trying to do when we're finding the area of the trapezoid. So when we look at example 1, I see that the flat parts are at the top and the bottom. It doesn't always happen that way, but it's on the top and the bottom. So those are my bases. So we're going to have 15 plus 17, because we have to add our bases. Multiply by your height. So we learned yesterday that we can find the height by using the right angle box. So that always connects your base and your height. And then we're going to divide it by 2, or multiply by 0.5. So 15 plus 17 times 7. And then divide by 2. And you should get 112 inches squared. All right, so number 2, I do want you to try it on your own. Just remember, add your bases, multiply by your height, and divide by 2. Okay, so if you did it correctly, you would have taken your 12 plus 16 times 4.5 and then divided by 2. You should have gotten 63 feet squared. So it's in feet, we know area squared. Now, number 3 is a little bit more challenging. So if I kind of look at that equation, we know we're going to have the 8 plus the 18. Those are our 2 bases. So that's your 2 flat parts. And then we would need the height. So the height should be where the right angle is, and we don't have that number. But as we've been working through this, we've been seeing different times where we had to use Pythagorean theorem to find a piece of a right triangle. So I want you to kind of look at this piece right here. So this right triangle piece. So on that piece, we know that this is 11. And I can figure out how big this bottom part is. If I know this whole length is 18, and I know that this much is 8, 18 minus 8 tells us that this part is 10. So now I should be able to find the height of this right triangle using Pythagorean theorem. So we know the box points to your C part. So if I think about a squared plus b squared equals c squared, we're going to have x squared plus 10 squared equals 11 squared. So 10 squared is 100. 11 squared is 121. Subtract 100 from both sides, we get x squared equals 21. And then we discussed that to get rid of that x squared, we have to square root both sides. Now, for ease, we're just going to round this to the 10th spot. So if I round this to the 10th place, we're going to get 4.6. And now we can put 4.6 in for our height. So we just found out that the height is 4.6. So this is 4.6. Okay, and once I do all that, we have to divide by 2. So 8 plus 18 is 26. 26 times 4.6 is 119.6. And then we divide by 2. Your final answer here should be 59.8 inches squared. So 59.8 inches squared. Okay, so we've gotten through the harder one. So trapezoids was the hard one for today. We did that one first. Now we're going to talk about rhombus and kite. So rhombuses and kites have the same area formula, and it is just 1/2 d1 d2. So again, 1/2 d1 d2. So instead of b for bases, we have a d1 and a d2 for diagonals. So you just got to keep in mind that these are the d's, as in dog, as opposed to the B's as in bases for the trapezoid. All right, so looking at number 5, all right, it tells us this is a rhombus. And on a rhombus, these diagonals are kind of cut in half. So if this part is 15, then I know that this part down here is 15. And if this part up here is 13.5, then I know that this one down here is also 13.5. So each diagonal or each line going through the middle of your shape is cut in half on a rhombus. Okay, so to find the area, we just need to know that the complete diagonals. So we're going to have this whole diagonal here, which is 15 and 15, so that's 30. And then the whole diagonal here, which is 13.5 plus 13.5, which is 27. So 30 times 27, and then we're going to divide by 2. And you should get 405 feet squared. 405 feet squared. Look at number 6. So this one is the kite. So it's the same formula, the 1/2 d1 d2. So if I just take one of the diagonals, so let's do the one going left and right, 9 plus 9 is 18. And then I take the other one, 4 plus 12 is 16. So 4 plus 12 is 16. Now I just have to multiply 18 times 16 and then divide by 2. So 18 times 16 divided by 2. We get 144 feet squared. Again, it's area. Make sure you label it squared. 7 and 8 are the same kind of problems. It just didn't give you the picture for it. So it tells you this is a kite. It tells you the diagonals. So we know it's 1/2 the first diagonal, then the second diagonal. So 13 times 14 divided by 2. 91 centimeters squared. And then number 8, this is a rhombus. It tells you what the two diagonals are. So again, it's 1/2 16 times 21. Again, 1/2 of 16 times 21. So 16 times 21 and then divide by 2. We're going to get 168 feet squared. 168 feet squared. So that pretty much sums up trapezoids, rhombuses, and kites. So now you've got a total of 6 figures we've talked about. Just as before, if you have any questions, please feel free to reach out and I will try to assist you in any way we can. Thanks. Bye-bye.